we left off with what? What was the last thing in your notes? Oops, that does not count as a bonus extra credit. That's Kate's timer. So. However, I probably don't have this muted, so.
Special cases for the elasticity of demand.
Okay. So we did perfectly elastic, perfectly inelastic, and today we need to kind of wrap up the elasticity talks with at least writing out the other formulas, which all fall right in line with each other. So let me check out your notes here from last time to see exactly where we left off. Okay, so we did that, showed the range. Okay. So I think that pretty well completed the price elasticity of demand, and we'll also need to be familiar with these other cases, which were also covered in principles class. So I just want to write them out now. The income elasticity. All of these formulas, as you go back to kind of rack your brain, look very similar. So it's the percentage change in the quantity demanded, the quantity people want to buy, based on their change in income. I'll come back to that in a sec. So if you're kind of stuck on this formula, sometimes go back to your new number minus the old number divided by the old number. So the change in quantity divided by some initial quantity, let's call it Q0, and the change in income divided by some initial income, and then just reduce that down, and it'll start to look like some of the formulas that you'll see in your textbook. So a problem will give you, okay, current income is $20,000, the current amount being sold is 875 units, so those are your point estimates for a given problem, and then there'll be some sort of change or a couple numbers to work with. The key here as it relates back to the demand curve is our two cases of normal goods and inferior goods. So in the case of a normal good, the sign of the income elasticity is greater than 0. It's a positive number. More simply put, if there's an increase in income, it leads to an increase in demand, which is a shift to the right of the regular demand curve or the inverse demand curve? Inverse demand curve. Technically, when we're looking at it this way, we're thinking about the inverse demand curve. Now, what's the inverse demand curve again? As opposed to the regular demand curve?
What we're used to.
Yeah, what we're used to. That's a good way to put it. How about a little more formally in math terms? It's got a negative slope, but a little more than that. Okay, good. So it's how we express the formula. So the regular old demand curve we think of as people making decisions on how much to buy as some function of price. Now, I'm going to add on to this a little bit today, but there's other things that go on into that decision. Price of that good is one of them, but so is your income. So is the price of related goods. So you're going to have a homework problem. Did anybody sneak ahead and attempt any homework this long weekend? Are you all cramming for Friday? Remember, homework number 1, chapter 2, all the starred equations are due this Friday. You're going to see a problem like this. So this demand function is multivariate, right? There's multiple variables that go into the decision of how much stuff should I buy. So I'll just stop with those arguments. We could have the all 5. All of those things that were shifters are now potential arguments to the demand function. All right, so if we manipulate the equation, solving for P, now we've got a function that has the quantity demanded as an argument along with income and price of related goods. That's all I've done is flip-flop these things. So this is inverse demand. This is the one that we are used to because when we graph it now, we've got the P on the vertical axis as opposed to up here. When we deal in equations, a lot of times we stick in this space because that's really the economics going on. The choice variable is the quantity, dependent upon these other things. What you're going to see in your first or second homework problem is they're going to give you an equation that says, I'm just going to make up one here. Quantity demanded is equal to, let's see, negative 10p plus 40i plus 0.6 PRG. And maybe even for fun, we'll just throw a constant term in there, plus 100. Now, this turns out to be very similar to how we go about estimating demand in the real world using statistics. So we're going to collect data on income of a particular person who bought a particular quantity of a good. But that's just one observation. And so that person on that day bought 6 units of the good at a price of here, and their income was $10,000. Another person purchased 8, and their income was $20,000, and their details were this, and this, and this, and this, and this, and this, and this. And we collect data on 100 different people, and that's our data set now that we could be looking with our schedule goggles on an Excel spreadsheet of all observations of individual purchases. Ultimately then, using some statistics of regression to fit a line through these data points, coming up with the estimated demand for this product. Okay, Chelsea?
So, like I know at other times when we like looked at demand, supply and demand, we had like ceteris paribus where it's like everything was remaining constant. So like in this, would you have to for one demand curve, would you have to have a constant income, or could it be that you have different incomes and different prices? Like I don't know, can all of those vary, or does some of those have to be constant?
Okay, loaded question, but a good one. So when we estimate the demand curve, kind of sky's the limit. It's kind of, I guess, ceteris paribus for that particular person at that particular point in time. We know that they bought 6 units, and this was their income, and this was their this, and this was their this, and this was their this, right? So it's kind of a ceteris paribus data point for that individual. And that individual, and that individual, and that individual. And now we're looking at the market demand curve, the collective behavior of a whole bunch of individuals, and we can start to make inferences about how income influences decisions of this, purchases of this good. So there's my estimated market demand curve based on the collection of a whole bunch of individual behavior. Now, back to your original, or maybe set part 2 or part B of your question. These estimates that we have out in front of these numbers from this line, if we were to kind of, it would basically look something like this. Now reflect the elasticities for changes being made to income. Now that's where we get into the prediction business. And we say, suppose we know that the price of our substitute good is going to rise 10%. How is that going to affect my sales? Well, I've estimated this demand curve based on some previous prices or collecting the data, and now I can say my sales are going to change by 0.6 of a unit. So this ends up being the elasticity of, whoops, I haven't gotten there yet, for cross-price elasticity. This ends up being that measurement of the response, holding all other things constant. Just that. So the way the sum of least squares works for estimating this thing is it isolates each one individually, holding the rest of them constant. So it kind of does what we set up in principles class of holding everything else constant, what's the effect on price, is done in a more sophisticated way here after you collect the data. Okay? This is bonus material right now, by the way. Just kind of want, I've got a problem that I'll probably show later. I want you guys to see the big picture of why are we cranking through these equations? How does it fit into what economists really do? This is what economists really do. So we collect data about the real world, which we may not understand perfectly on how sensitive consumers are to changes in these variables that we think are important. We collect data, we make statistical inferences. It's all based on these principles that we have, I guess, tested over time and believe that there's some appropriate statistical techniques to make these claims that these are now legit estimates. Okay, that's a quick flyby. Anything else? Good question. So I want you guys to see where that stuff goes, and I probably went a little bit more detail, but you're going to see this in the equation, or that first example. Now, how they're going to do, what they're going to do is simply say, okay, suppose income's 20,000. As soon as we give you numbers like this and say, suppose, here comes the big assume, suppose I equals 2,000 and PRG equals 46. Once I give you numbers, what happens to this equation? You can solve it how far down? To P, which changes it into slope-intercept form, and we're right back into our world of, if I substitute a 2,000 into here, 40 times 2,000, 46 into here, 46 times 0.6, plus 100, this number plus this number plus this number equals a number. So all of this collapses down into the intercept. And now we're back to slope-intercept form. Okay? All right, so we can isolate that. We first go about learning the variables that we think are important, thinking about how people respond. We do have ways to estimate people's responsiveness. So the elasticity, the income elasticity is simply a number. Let me write out inferior goods first, and then I'll give you that definition. So there's normal goods. The other case was an inferior good. So the income elasticity is a negative number, something less than 0. So it might be negative 0.5, negative 1.37, whatever. So it's a negative number, which implies that an increase in income leads us to buy less ramen noodles. So the definition here of an income elasticity is a unitless number that shows the responsiveness of quantity demanded to a change in income. Okay, cross price elasticity. I kind of want to make sure that that's what. I think that's what the book calls. Cross price, yeah. Okay. Cross price elasticity. Again, basically the same formula. Okay, they do, I'll try to stay consistent with their formula. The cross price elasticity between X-rays and yo-yos, X and Y, this is using their notation, I would have chose at least apples and bananas or something, equals the percentage change in the quantity of X-rays divided by the percentage change in the price of yo-yos, Coke and Pepsi, peanut butter and jelly. And that breaks down into the same way we did before. Price of good Y over the quantity of good X. And if it's helpful, I mean, the book actually calls this the cross price elasticity of demand. So we got the price elasticity of demand, which of course is PX down here, right? QX and PX, the price elasticity. This is now the cross price elasticity, analyzing the complements or substitutes.
And the PY and the QX at the end are like the original ones?
Yes. Again, with these things, we're dealing with point estimates of kind of where we're dealing with really one point on a curve. We're kind of treating this like we would with calculus, that it's an infinitely small change along some function, some demand curve, okay? That's why we do that. And I like that the book kind of just takes that approach and doesn't mess around with the other ones. But yes, you can think of it as the old. Okay. So that type of stuff, let me give you a little bit of a foreshadowing, especially this one, but all of these. This will be helpful in later chapters on strategic pricing. How do we price our goods? When we look at goods with multi-products that are complementary with each other or possibly substitutes with each other, how do we price Coke and Pepsi on the shelves at Walmart? We've got one store that's got two goods that are substitutes. Should one be on sale and one be high priced, and then kind of rotate that around? Should they both be on sale at the same time? You know, different ways. How do we maximize profits given circumstances like that? All right, anything else on this? Okay, chapter 3. moving right along. We're getting into welfare analysis, consumer and producer surplus. This chapter will give you some repetition if you're still a little foggy on how we work with equations of supply and demand. This chapter will play right into that. You'll get extra practice doing it. But we are going to add on the dimension of consumer and producer surplus. So, welfare analysis of the market. All right, so consumer and producer surplus. You've got the notes. Sam, did you end up getting notes yet from Cadence? Great. Okay. So I've got definitions in those principles notes, so I'm not going to spend the time going through that again, but I'm going to hopefully re-engage your brain on what these things are. So if you draw home base in our market, we've got supply and demand. We had a special name for these vertical intercepts. What was it? The choke price. So we got the supply choke price down here. In other words, price has to be at least this level for somebody to be willing to supply. Otherwise it gets choked off if price gets too low. Zero, remember this is our origin, so nothing gets supplied to the market if the price is too low. On the flip side, on our buyer side, if the price gets too high, we eventually choke off the consumers and they buy nothing. So we got these endpoints. Okay, consumers and producers get together on exchange, equilibrium quantity, equilibrium price, and there we got it. So the idea of welfare analysis is that there's people out there on the buying side that have benefits above and beyond the price that they paid. So they were people that placed a higher value internally. Their marginal benefit was higher than what they actually had to pay. So if the price of this good was $10, somebody out there got a deal, and we've all gotten these kinds of deals. So consumer surplus is the difference between what we're willing to pay, which is the height of the demand curve. Somebody was willing to pay this number, but they only paid $10. So they got a deal of this vertical height, which is a dollar value measure of how much of a deal they got. They're like, hey man, I was willing to pay $14, but I only had to pay $10. I got a $4 deal in my mind. Well, somebody down here is our real high value customer. Even if prices got real high, they have to have their energy drink. And they are willing to pay whatever it takes almost. They can be choked out of the market too, but this person would be willing to pay what I got here, 4, 2, 6, $16 for that energy drink. And so when they actually got to pay $10, they're like, sweet, I got $6 worth of consumer surplus for the purchase of the energy drink in the market. So if we go through and analyze the difference between what consumers were willing to pay and what they actually paid for each unit that they consumed, all the way to the actual number of units. And what was the consumer surplus on this last unit if this was 100 units? 0. So they got $0 of consumer surplus, but don't be too worried about that. They didn't get screwed. They just happened to pay exactly what they were willing to pay. It was a fair deal for them. No big deal. They just don't have any bonus surplus to them. All right, so if we add up all of the consumer's surpluses for individual units, it will look like this triangular region here. So that is consumer surplus. And the one thing we might put on here, I guess, is one note. I do want you to keep in mind that it's a dollar value measure of welfare. It's a dollar value estimate of welfare. And when we say welfare, we're not talking food stamps and unemployment. We're talking well-being. The well-being of the consumer is what we mean by welfare of the consumer. Now, if it's just a triangle, which it doesn't have to be, as we learned in principles class, if it is a triangle, though, how do we calculate this area? 1/2 base times height. So note that the area of that is 1/2 base times height, our good old-fashioned geometry formula. All right, well, producers benefit from exchanges in the market too. We know that they're in it to maximize profits. Producer surplus is similar to profits, but not quite exact the same as profits, which we can get into in later chapters. But right now, I want you to think about the difference between what a producer needs to get at a very minimum and the price that they actually get. So let me back up one sec and refresh your memories on what these supply and demand curves reflect. The demand curve is the marginal benefit curve, and the supply curve is the marginal cost curve. The cost of an additional unit, remember, substitute in the word additional for marginal just about any time. So the cost of an additional unit, the benefit of an additional unit. All right, so for the producers, they got $10 for producing the 50th unit. They got $10, they sold it for $10, but the minimum amount they needed, which would be just to cover their cost at the margin, the absolute rock bottom minimum that they needed to even bring this to the marketplace was, looks like I'm right in there, $5. Maybe it's $5.10. $5.10. So the producer surplus that they got, kind of the profit on the marginal unit, the profit on the marginal unit was $4.90, which is this vertical height for the 50th unit. We go back, we do that for each one of these units, and we get the producer surplus, which is a dollar value measure of welfare for the producers. It too, in this case, the area of a right triangle that looks like that is 1/2 base times height. All right. Questions? Here is our problem today. We have a demand curve and a supply curve, and I need you to calculate consumer and producer surplus. Now read the question, and then I want to at least discuss our approach to it. So what's your approach? What's the first thing you think how you want to approach the problem? Okay, figure out A. Good. And how do you figure out A?
Rearrange the equation so it'll equal to P.
Okay. Would everybody take that approach? Rearrange. So you want to shuffle solve the equations for P first, and then solve it that way?
Yeah.
Anybody have a different approach?
Set them equal to each other.
Set them equal to each other would be saving you a step at this point.
I didn't really, I just thought you could do it since it's two different things.
Yep, and that's why I wanted to bring it up. Think about how you're approaching it. So in equilibrium, quantity demanded, we're basically solving for this number. Quantity demanded equals quantity supplied. So it's okay to set those two equal to each other and solve for P. You're going to be solving for this number. So, and then we'll take it from there. But do that step first. Go ahead and set those two equal. And it might not hurt, as you're learning this, to say in equilibrium, Q star equals quantity demanded equals quantity supplied. And so that's the justification of what we're doing, setting those two equations equal to each other. Look good? What's the next step? Plug it back into which one? Either one. So it doesn't matter. So sub P star into either equation. $137.
Yes.
Okay. All right, so let's see. Part A was find equilibrium price and equilibrium quantity. So if you were to draw a quick picture now, I think it wouldn't be a bad idea, just for conceptual purposes. At least this is the way my brain works. Some of you more mathematically minded people might just kind of whip this out. But to me, I might like to do, okay, I got 75 cents here, and I've learned that the equilibrium quantity is 137. Because the next step, calculate consumer and producer surplus at the equilibrium price. What's your approach? Choke price. So if we're going to ultimately work our way back to 1/2 base times height, our missing link here is the choke price for each. How do we find the choke price? What's that, Rhiann? Slope-intercept form.
In terms of
Solving for P. Yeah, so now we got to go back to the solving for P. So Brinson's work wouldn't have been necessarily wasted, but not needed at the time we did it, right? So now we need to find this intercept, which is the inverse demand curve, right? Or how would you do it? What's your approach, Chelsea?
I just set it, like, I set the original equation we had, so like 152 minus 20p equals 0.
Yep.
Instead of like switching it around. because
Okay.
it's extra.
So we know that the quantity equals 0. So we can take our demand equation, which I have written here, and set this equal to 0 and solve for p. Right? So you don't actually have to manipulate the equation back to its functional form, which was going to save you a little bit of steps. So the key for starters here is to find the choke price. We know that, I'm going to do it in full glory here, 152 minus 20p. There's our demand curve. And if I understood you right, you're just substituting in a 0 here, right? So let QD equals 0. Therefore, we got 0 equals 152 minus 20p. And what did you get for an answer? Anybody get it yet?
$7.
Yeah. How much?
$7.
$7.60, 7.6. So P equals 760 for the demand equation. So we're up here. Of course, this isn't drawn to scale, bear that in mind, but for me this just kind of helps complete the puzzle pieces and keep your brain focused in. What'd you get for quantity supplied? We can do the same thing for quantity supplied.
Yeah.
How much?
2 cents.
2 cents? Okay. Sounds good. So set QS equal to 0, and we get P equals 2 cents. So we get 0.02 over here. Next step.
137 is going to be your base for either, can be your base or your height, whatever you
Yep.
really want to look at it.
Okay.
And then sulfur is your consumer surplus.
Go back to your geometry right here. So the area for this, the area for this, you've got all the points. Go for it. Base of 137 times a height of 760 minus 0.75. What'd you get for consumer surplus?
Consumer was 469.23.
469.23.
Yeah.
Okay, now let's stop there for a second. One thing we gotta always be careful of is what our units are in. Is that 469.23 units?
It's dollars.
Dollars, okay. How about the quantity? So go back to this and say, I'm measuring this in dollars, unless it's in cents. That last problem we had was in cents. So go up to the original equation, where Q, the demand and supply curves are these functions, where Q is measured in thousands, and P is measured in dollars. So what is the real number here? The real number here, I guess one way to think about it is 137,000. So we could go back and shove the zeros in here, or it's completely legitimate to then shove them in here. So we've got $469,000 worth of consumer surplus. And then producer surplus. 1/2 base times height. 1/2 137. That's fine. You can keep the calculator entries a little easier that way. You just got to remember to convert at the very end and double check that. So 137 times 0.75 is the initial equilibrium price minus 0.02, which is our supply choke price. And what'd you guys get for that?
I might be off, but I got 49,920.
49,920. Sounds like
50,005.
50,005. That's the right answer. So a little bit of rounding there. So 50,005.
I just did round 2 cents at the very beginning. What? Are you wanting us to round off as soon as possible in this case, or in these cases, or?
Where did you round?
I didn't round.
Oh, you didn't round.
The 2 cents I kept as 0.0214,
It's like 0.0214
something like that.
Oh, there was some rounding there. Yeah, yeah. When we're dealing with dollars, since we don't do fractions of dollars, you can round it to the 2 cents at that time as we work through the problem. Okay.
For the producer surplus, consumer surplus, I got 469,225.
That's right. Yep, 469,225. That is the correct number. I still had. If you show all your work, I'm not going to ding you much. I'm not going to promise you that you wouldn't be dinged a little, maybe, but depending on the problem, depending on the circumstances. But yeah, rounding errors are not what we're all about. We've got to be able to figure out how to get to these answers. All right, so the dollar value of welfare to consumers from this market, $469,000. Dollar value welfare for producers is $50,000. So when I drew my little home base there, bear in mind that that's not the way this really looked. If you drew it more carefully, the supply curve was probably really elastic, and the demand curve was a lot more steeper relative to supply. And so there was our 75 cents, and we've got producer surplus equal to this area, and consumer surplus equal to this. Visually. Again, it's not required for the problem, but conceptually, be thinking about those relative elasticities. What we're going to do on Friday is go back and think about the relative elasticities. Remember where we're going with this ultimately in this chapter. This is going to bring in price controls, price floors, price ceilings, taxes, subsidies, just like we did in the past, so we can analyze the welfare effects of government policy. All right, we'll see you on Friday. And you turn in your homework at the beginning of class Friday. And that'll give us an opportunity to maybe flesh out questions that you have on it too. Yes, handwriting. Yep.
Which one did you
The starred questions.
Starred ones?
Yep.
Okay.
So here, I don't know if I showed you this before, you guys. If you're wondering about the problems, so they got a little asterisk by the number. Okay? And there's 6 of them. And the answers are in the back.
Russ.
Yeah.
So. Copy not for resale as well.
Oh, really? What do you mean as well? You got?
Yeah,
oh, you're just
I
saying
got
you
the one
got
that
my
you
copy.
And
The
so-
black market.
on
This is
Amazon.
yeah, you can write a whole research paper probably for your thing on how that disrupts the marketplace. John, you're next. Okay.
How much? I have a question. Do you subscribe to a service that gives you textbooks like that?
All the reps. I mean, we're kind of the feeder supply, right? So when I'm thinking about this intermediate class, I looked at like 4 textbooks. So as a service, they give us complimentary copies. Or once we adopt the book. We also have digital versions we can look at. So somebody got a copy of the book and dumped it off on the market, even though there's like words on there that says please don't do that, disrupt the market. It happens.
Because it was also advertised without the not for your resale portion of the cover.
Yeah, that's interesting. You know, honestly, it wouldn't be bad for you to report that to Amazon
Yeah.
because it's just something they should know about. Let them decide what they're going to do or if they're going to do anything. But at least you've kind of done.
I paid market value.
You paid market value for, yeah, it sounds like you paid full price for what should be the brand new legal textbook.
Exactly.
And actually, this is a bigger, I didn't think about this. That causes you some problems on resale yourself. Even though I think you were talking about maybe keeping it, but you should contact Amazon on that because, yeah.
I mean, it was through a third party, but still, their vendors should also be holding to their policies.
Yeah, if it didn't say that, yeah, because when you go back to resell that, that's going to discount your value.
What
to
all the emails from the guy that sent it to me said were, this is an instructor's copy, this isn't a complimentary copy, if that makes sense.
Oh, so they did kind of tell you
They
that.
said it's an instructor's copy. And so I'm like, oh, it's
You
like
wouldn't
the
have-
teacher's edition.
I mean, that doesn't, yeah, you didn't really necessarily know what that meant, but that is what that means, so.
I'm talking about for the creativity exercise in the leadership class.
Yeah.
We're supposed to turn in the plan today, the outline.
Yes. I'd like at least the draft of the
Okay.
of
Can
the
it be
timeline.
right hand or it's gotta be typed or I mean you want to?
I'd like that to be typed.
Type in your email.
Yes.
Alright.
Yep.
Alright. Thank you.
Okay.